So here we have a problem. Given an array of non-negative integer and an integer sum. The task is to count all subsets of given array with sum equal to given sum. So here non-negative means we can have either 0 or some positive number in our entire array. So this problem can be solved by using dynamic programming. First we will write the recursion logic and then we will transform it into a dynamic programming problem. So let's say we have an array something like this. We have all the elements in my array. Now let's start picking each element from the end of my array. So size of array is n, so this element which is at last position will have index n minus 1. So for each element e I have two choices, whether I include it in my subset or I will not include it. So we can include or we cannot or we may choose to not include that particular element e in our subset. So we want to make a subset whose sum is equal to given sum. So let's say this element e can be a part of that subset or cannot be the part of subset. These are the two cases. This is case number 1, this is case number 2. This element will be a part of that subset or it will not be a part of the subset. So what we will do, for case 1 we will get the count. So in case 1 we will count all those subsets whose sum is equal to given sum and in which e is included. Case 2, so this will give me a count 1, let's say. In case 2 we will find out all the count of all the subsets in which e is not a part of that subset. Let's say this is my count 2, that I'll get a count. And what will be my answer? Answer will be count 1 plus count 2. Let's write the recursion logic for it. Recursion pseudocode. So in our get count function, let's say I'll name it as get count. It will return an integer value. That integer value is basically the number of subsets that are possible and which have sum equal to the given sum. It will accept the parameter our array. It will accept the size of my array and the given sum. So let's say my first element is arr n minus 1 and I want to include it. So there is a condition that this element must fulfill in order to include it. That condition is this value arr n minus 1 must be either less than this sum value or equal to this sum value, because if it's greater than sum then we can't include it, because we can never have it in a subset so that sum become equal to given sum. So to make a sum from taking an element, that element must be less than or equal to that sum. So if this element is either less than or equal to my given sum, then I can include it. Okay, And let's say let's create a variable answer equals to 0 to store our answer. So if I include it, I'll recursively find out the answer for rest of the code, rest of the array. So let's say I'll recursively call for rest of the array will be same, but now since I have included it, the size of array will get reduced by 1, and sum will also be reduced by the value that is equal to this element. So sum minus arr n minus 1. This will be my new sum, and this is my new array of new size of my array. So this will return some value, and I'll append that. This will give me a count on the sub problem, and that count I will append in my answer. Right. So this is the case when I included it. Now the second case, I'll not include it. Was not included. So if I don't include it, I'll get a count, and for that array will remain same, size of array will get reduced by 1, and sum will remain same because I have not included it, so sum will not be reduced. So whatever I'm count getting from this recursion call, I'll append that count in my answer. This way I have considered both of the cases, and I got the union or total count that is possible. So in the end I'll just have to return the answer. This is how our recursion will work. Now one thing is missing in this recursion is the base condition, like what is the smallest possible sub problem where we will stop our recursive calls, right? So let's think of the base case. Now base case will arrive when we have no elements left in my array to make further recursion call on that. So when the array become empty, so base case arrive when array will become empty. And how can I know that array is empty? But if array is empty when n is equal to 0. When n becomes 0, then now the array is empty, and now we have no element to make further choices on them, right? So in the base case, we will simply say that if my n is equal to 0, then that means the base condition has arrived. And now if we were able to make the sum 0, if we have arrived at sum equals to 0, then this means that we have found a subset whose sum is equal to the given sum, because we keep on reducing the elements from our array, and by doing that, if I keep decrementing some element from my sum array, if we arrive at sum equal to 0, then that means we have found a subset whose sum is equal to the given sum. So that is one subset, so I'll simply return 1 in that case. But if sum is not equal to 0 and we have no more element left in my array, then that means whatever choices we have made, those choices didn't give us a subset whose sum is equal to given sum. So in that case, we will just return there is no such subset we found till now, so we will return 0. This is my base condition. So just add this base condition uh, here at initial position of your recursion code, right? So base condition will arrive when your array becomes empty. Now to optimize this code, you can use tabularized dynamic programming, in which we declare a vector. Let's say I'll call it t, whose one coordinate is since in our recursion only two variables are varying, one is n and sum, other is sum. Array is constant, only n and sum is varying. So let's say one dimension of my array is n plus 1, and second dimension is sum plus 1. So it will keep the answer of all possible pair of n and sum. I'll iterate the first coordinate using I and second coordinate using j. So in tabular dynamic programming, we first start from the base case, right? From we fill the array with the least possible answer, that is from the base case, and in the base case we can see that we find base case when n is equal to 0, and this means when I equal to 0, that is I is 0, then we will write it like this, and when I is 0, we will check if sum is 0. If sum is 0, then we will return 1. If sum is also 0, then that will become 1. But when sum is not 0 but I is 0, then in those cases we will have the value 0. So I'll vary j from 1 to sum plus 1. I want I to be 0 and j to be a non-zero value. In that case we will get 0. So this is how we use the base condition to initialize our table. Now to further fill up the table, just iterate all possible combinations of I and j. So for int I equals to, since we have covered all the cases belong to I0, so when I is 0 we have covered j is equal to 0 and j is equal to 1 to sum plus 1. So we don't need to again start iterating from I is equal to 0. So we'll start from I equal to 1 only, then we will go till n plus 1, iterate there. For j, for sum, we haven't covered all the possible pairs of j is equal to 0 corresponding to non-zero. For j is equal to 0, we have not covered all possible i's. So we'll start from j is equal to 0, j less than sum plus 1, and j plus plus. Now you know what we want to do. We just declare a variable of answer equal to 0, and if now you can see the recursion to write the logic of dynamic programming. Here are n minus 1 less than is equal to sum, so n will get replaced by I and sum will get replaced by j. So if my ARR I minus 1 is less than equal to j, then we will include it, and answer will be plus equals to t of, now size of array will get reduced by 1, so I minus 1, and new sum will be what? Current sum minus this element value which I have taken, AR I minus 1. Okay, and if we don't include it, in that case answer will be t of I minus 1, and sum will remain same since I haven't included it. So answer of this pair ij will become this answer. In the end, after we have covered all the possible cases of I and j, we'll just have to return t of n sum, because that's what we wanted. We want the answer for this particular pair when the size of array is n and the given sum is equal to sum.